Hi, my name is Courtney Turner.
And I'm Cameron Simpson.
We're going to tell you about some of our top products and how you can tie them all together. We found that different engineering groups have different requirements, which oftentimes means they need different types of instruments. While the design teams generally sacrifice cost for quality and time to market, validation and compliance teams sacrifice time to market and test for quality.
This can cause a lack of efficiency, which can result in increased time to market, decreased quality, and excessive spending.
Yokogawa offers a variety of products for each of these engineering groups and the solution to synchronize, configure, collect, and analyze data from all of them to increase efficiency and decrease cost across teams.
The WT5000 is our highest accuracy precision power analyzer. It has 7 swappable and reconfigurable input elements, plus up to 4 motor channels to measure both electrical and mechanical power under one measurement system.
The DL950 scope quarter combines the ability of a mixed signal oscilloscope to capture high-speed transient events with the capacity to record long-run trends. With over 20 types of isolated input modules and 8 modular slots, the DL950 can measure 128 channels of voltage and current, temperature, vibration, acceleration, strain, and other electromechanical and physical phenomena.
The DLM5000 is a compact 8-channel oscilloscope that offers a large touchscreen, extensive triggers, math channels, vehicle serial bus, and other analysis features to provide the flexibility users need to capture every measurement.
While all these instruments are great standalone, some applications require accurate power data, fast sampling grades, long recording, and insights that only waveform data can provide.
Our IS8000 software unifies the WT5000, DL950, and DLM5000 into one display for viewing, measuring, and debugging across multiple waveforms.
With one software to set up and control all the instruments you need, you can start measuring data faster and more efficiently.
IS8000 also allows you to store data in one format and location that can be opened for analysis in the software or exported to a CSV file.
All of these instruments can also be synchronized utilizing IEEE 1588 for measurement data you can trust.
To begin assembling our system of instruments, we'll set up the connections between each device and IS8000. For our setup, we'll be connecting our DL950 and WT5000 to our PC through an Ethernet hub. This will allow an Ethernet connection between our instruments to support IEEE 1588 synchronization. The DLM5000 can also be connected in this manner. To set up synchronization between the instruments, we'll first go to the DL950 and enable IEEE 1588 master control. First, press Utility, then System Config, then Time Sync, and set this Time Sync setting to IEEE 1588. We'll then press IEEE 1588 Setup and set the master mode to Master/Slave. Next, we'll enable the Time Sync on the WT5000 by going to Setup, then Utility, and then to the System Configuration menu, and enable Time Sync in the bottom left. Be sure to choose matching settings with your DL950 for proper connection, including network layer, E2E, domain number, etc. The sync calibration period may take a couple of minutes, so you can monitor the progress by pressing the information button at the bottom of this menu. After our hardware is all connected and synced, we'll launch IS8000 on our PC and press New to open a new DAC connection for each instrument. We can use the automatic device search function to find our instruments, or we can find them manually with the address information. When our instrument is located by IS8000, we'll press Open to start a new DAC connection.
The window will now show the waveform capture view, as well as other menus for adjusting device settings and channel settings on all the connected instruments. We'll combine the windows for our units by pressing the ellipsis next to the WT5000 under Devices and starting coaxial connection. We'll also be sure to make the necessary changes to the device and channel settings so that our measurements will show up as expected. When we're ready to capture measurements, we'll go to the Control tab in the Monitor ribbon at the top of the screen. The ribbon will now show the options for controlling the measurement. We'll press Record to begin recording and verify that all our data is being captured. Please note that when you use the Start button to begin monitoring measurement, data is not being captured unless you also press Record. While this measurement is running, you have the option to perform a manual file division if you selected that option in the DAC setting menu.
Once the test completes, we'll stop the recording, stop the monitoring, and verify that all of our data has been saved to our PC's storage. Now that our data has been saved, a new window for analysis will open with all of our recent data. We can also access this file later from its storage directory using the pathway shown in the DAC list submenu. We have the option of adjusting the layout of our data in IS8000 by clicking the header of each subwindow and dragging it to a new orientation shown by hovering over the tiles that appear. If desired, we can change the layout of the data in the main window by clicking within its area and using the main properties menu that appears on the right. We'll change the split to 3 to get a better view of each trace's level. We can also create a zoom window by pressing one of the zoom buttons under the view ribbon at the top. Once it appears, we'll drag it to a new position and adjust the split property to view a single waveform. Using the Zoom 1 cursors that have appeared on the main window, we can coarsely adjust the horizontal zoom. For finer zoom control, we'll click within the zoom window area and use the horizontal scaling button in the zoom properties menu.
Lastly, we can convert the data to CSV format by pressing File, then Export to File, and then selecting the CSV extension from the File Type drop-down menu. When CSV is selected, ASCII file settings like time access information and decimal point type are available. When we've selected the channels that we want saved and the settings for the CSV file, we'll press the Save button at the bottom and specify a file name to complete the conversion.
That's all for our demonstration today. In summary, we introduced our suite of instruments and the software solution that ties them together, demonstrated how to synchronize them with IEEE 1588, and showed how to connect and manage data from them using IS8000.
We hope this video helps you let your instruments work together so your engineering groups can work together. Please check the links to the product pages in the description and visit tmi.yokogawa.com for more information. Thank you for watching.